Hi, Dave Sparks, I guess is what he said. I'm with the Android media team. I've been with Android for almost 2 years now, starting with in October 2007. So today's topic is about the media framework. I basically came in to work on the framework, and so I'm going to try to give you a quick talk. This original talk was an hour. Try to cut it down to a half an hour and see how it goes. So quickly, we're going to go over the framework itself, kind of a really deep dive into what the framework looks like, some of the security things that we've thought through in the framework to prevent security issues, some of the features of Android 1.5, which came out in what we call Cupcake, and then if we have time, we'll go over some common problems that people have when they're dealing with media framework. So talking about the architecture, some of the goals that we had when we started designing the media architecture was to simplify application development. We wanted to make it really simple to write an application that produced sound or played video or whatever. So we provided a really simple interface to be able to do those things. The other thing is on these embedded systems, you have very limited resources, as I'm sure you're all aware of. And so we wanted to have a way to share all the resources in a common and have them managed by a single process. The other piece of that's really difficult is if you're writing efficient codecs, it's very difficult to make them free of any security bugs. So we're going to have a strong security model that prevented exploits through the media framework. And obviously we wanted to be able to have expansion for future growth. So when you look at the framework, at the very top of the stack is the application. And then we have a separate process called the media server that actually does all of the media applications. So that dashed line in the middle is a process boundary between the application itself and the media server process. The media server, when it generates its audio and video, is going to generate it through one of the two services that provide audio video services, Audio Flinger, which basically is a mixing engine that takes multiple streams of audio, mixes it to an output. It could be Bluetooth, it could be the speaker, a wired headset, whatever. And then the Surface Flinger, which is the 2D composition engine for Android that takes all of the windows and composites them down to a single 2D frame buffer that is an output to the hardware. So when you look at the stack for a typical media call, at the very top of the stack is the Java application. And it's creating an object which is a proxy for an object that's actually in the media server process. So if you've looked at the Android stack, when you create a media player object in Java, it's actually a proxy for native resources that are living in a separate process called the media server. So the very top of the stack is a Java proxy object. It could be a media player, it could be a media recorder, it could be a camera object. There are a number of different ways that we abstract things. That then goes through a thin layer of Java native interface, which basically just takes it down to the native proxy. The native proxy layer, if you've looked at the code stack, we have things called like mediaplayer.cpp, mediarecorder.cpp. These are the native objects that represent the client side of the media server process. So the reason for doing that is that in the future we want to be able to allow development of native applications that take advantage of the media server process. So by having most of the code live in native code as opposed to in Java, when we allow people to do development of native applications, which we've just started doing with the recent release of the native SDK, you'll actually in the future be able to use these features from native code. And the nice thing about it is that the interface is going to be the same. So if you started writing an application, for example, in Java, and decided later on that you needed to move it to C code, the C++ interface looks very, very similar to the Java interface. So it's very easy to move the code down to native code. Then this is where most people get confused when they're looking at the media player stack. I've seen a lot of questions on the forums about, how do I trace the media player, let's say prepare call, to something that actually is going through instantiating the nodes in the media player as it's generating, like the codecs and the sync nodes, the source nodes, et cetera, et cetera. This is where it gets really confusing because you have this binder proxy. So the binder is an interface between two processes, inter-process communication mechanism, or remote procedures, if you want to call it that. So what binder does is it takes a packet of data and it turns it into a packet that's moved across the inter-process communication boundary. And so we have a kernel level driver that is responsible for doing that. And you basically just serialize the data, and then the kernel driver will move it into the other process. And that process has a number of binder threads, worker threads, that are responsible for picking up these packets and processing those. So the binder object, if you're looking at the code, if you want to follow the stack trace, mediaplayer.cpp then goes to something called imediaplayer. Okay, that's better. So mediaplayer.cpp makes a call into imediaplayer.cpp, and that's where the actual binder serialization takes place. So it takes the packet of data, and then through the kernel driver, will move that over to the media server process. And then the worker thread on the other side picks it up and acts on it. If you look at the media player interface, there's a media player service which picks up those packets when you want to, for example, instantiate a media player. And it creates a media player binder interface that it then returns back to the application. So now the application has an interface on which it can make calls into a media player that's created inside the media server process. And so that's the binder native code. And then the actual native implementation you'll find in mediaplayer-service.cpp. So for each call in the media player interface, there's a complementary call in media player service. It would be like media player service, media player client, and that's where the actual calls end up.